You see it? Yeah. Okay, wonderful. Let's start. Yeah. Okay. So, hello everyone again. Thank you for those of you who stayed and run away after the vision. Because security, privacy, makes everybody like, oh man, that's not what I hear. Okay, so talk 2 is about the security, privacy, and safety sort of projects that we've been doing. Some of them fit directly into GioTTo. Some of them are actually sort of in parallel working on how do you sort of make a safe IoT infrastructure. So we already talked about the Living Lab. You're already familiar with the team. This is the part that I'm going to be talking about. So Jason and I have been working on the security, safety, and privacy layer for GioTTo. And then I'm also working with 2 other faculty members, Vyas and Srini, and we actually have an NSF Trustworthy Computing grant on safety and IoT that we just got a few months ago. So just wanted to give credits to everybody. We talked about the stack. I wasn't sure how many of you would be new, so I just kept the same things. So here's the part that I wanted to make here. So look, we've been doing security and safety and privacy for a while, right? What about IoT makes it so different? I wanted to motivate that first, just to sort of set up the problem about why are these problems sort of even appearing in IoT? What is it about IoT that makes them different from a traditional sort of like desktop, laptop, mobile world that we're also familiar with? And then based on those motivations, see what potential solutions could we come up with that may help address what I think is a ginormous problem in case of IoT, and will actually affect whether these things actually get deployed in practice. So this is what we started off with. The first wave of computing was your computer with a desktop and like a big screen and keyboard. Then we went to the second wave of computing, which was sort of these like mobile devices, watches, etc. And arguably that's what we are in now. The third final wave of computing is sort of this IoT world, where computation is sort of in the fabric of all around us. We have sensing, actuation, everything is sort of ethereal. You don't even know where this is happening, and the hope is that with assistants like Google Now and Siri, and as well as all the other products, we're going to be our life is going to fundamentally improve because this infrastructure and everything around us will be able to know exactly what we want and know when it is appropriate to bug us because we are feeling really great right now, right? So all of this is going to be interwoven into the fabric. So it offers tremendous benefits, except you have this major problem, right? So we were in the first wave of computing, we were in this top tier where there were few devices per person, high computational power. Then we went to this middle tier where there were tens of devices per person, and arguably IoT is in this bottom tier where there are hundreds of devices per person. Often, many of them are lower computational power. Some of them are embedded in infrastructure like HVAC around us. You even have things like smart toilets and implanted medical devices. So these are all that are going to be there around us, embedded in the infrastructure, even sometimes embedded inside us, which sort of causes a whole new set of security and privacy problems. So in terms of security issues, we're all familiar with security issues, which were in the top tier and the middle tier, right? In the bottom tier, cybersecurity is actually very poor today. There's really weak or no endpoint protection. So what I mean by that is that, while like currently the 2 dominant operating systems are like, let's say, Windows and a Mac, you have endpoint solutions like antiviruses, firewalls, etc. IoT system is so fragmented that there is really no endpoint solution, and you're running on things that are, if at best, 32-bit ARM micros. Sometimes they're even lower than that. How are you going to put anything on those devices? Many of these are being manufactured by people whose whole goal is to get these devices into the hands of the consumer, because if you don't get it to them in the next 2 months, the company will go kaput. So security and privacy are the last thing that they're actually thinking about. High diversity in hardware, software, and operating system. If you look at these devices, they're extremely homogeneous. Processors come from Intel, multiple OSs, but really all very tightly controlled. And many devices are never, ever updated. This is what happens when that happens. It's like full of flaws. They're daily monitoring cameras to vulnerabilities of devices. And I'm sure most of you have heard about that whole din.com attack where, just compromised Chinese cameras were mounted an entire internet scale sort of DDoS attack and brought down much of the internet and many of these sites, right? And this is just the beginning, right? Often you could imagine that these devices could form the weakest link into your network, the whole assumption of your home network security is that that box that I buy from Linksys, Google, etc., are what are providing the NAT and the firewall that will protect me in case anything happens. The moment I bring my device to my side of the home, the assumption is all about usability. Can I discover using MDNS and Bonjour and ZeroConf, be able to find the devices, be able to configure them, install a smart bulb? All of that is going to come and bite us once we have even a single compromised devices that could provide a launching attack to many, many different scenarios, because the whole assumption of this home or enterprise network where there is sort of firewall gateway protections is not going to work anymore in the long run. And you could have several different launchpad attacks, and many of them are actually still coming. I'm sure many of you have been reading that. Just wanted to motivate that this is not something that's a pipe dream. It's actually happening now. We've already seen the first wave of attacks for compromised IoT devices. Now, the current approaches to IoT, security in IoT fail, right? In the IT world, think about this, right? You have the current world, you have a firewall, you have these machines, you have a computer, and then you add, as I said, some of this is repeating what I said, you have a firewall and antivirus patch. In case of this IoT world, you really have unfixable flaws, right? They are resource constrained, they are longly lived, right? Often you'll update your OS. People talk about Microsoft pushing patches and people not updating it, and often in time, you just went and bought a Belkin bulb, right? And you put it in the socket. That is going to have vulnerabilities for the next 10 years, and Belkin may not even be there, and nobody's going to patch it, right? What happens at that point? You have IP-based rules that you can configure in the IT world. Unfortunately, nothing like that, because often in the case of physical devices or IoT devices, there is an extremely niggly problem of physical interaction, right? So you could have two devices that really have no business talking to each other, right? You have, let's say you have a smart window, right? And then the other end, you have a fire alarm. You're like, what has the smart window got to do with the thing? And they all come with their own apps, right? Unfortunately, maybe you added a policy that says, if there's a fire detected, I'm going to open the smart window because I want people to be able to egress, right? So now what was sort of two independent systems are now coupled through policies. Often you could also have the same sensors and actuators in case of an IoT system share the same physical space. So a temperature sensor and a room heater in this particular space have nothing to do with each other, but they're all working on the same physical space. So heating on one could affect the sensors on the other, and these policies could get sort of coupled together. So now you're
all that different than where IT was a while ago, because it used to be on a system, you run a bunch of stuff, everything could talk to everything else, it was open. Then people started to figure out that was not safe. And this is just in the IT world, right? So then everything gets locked down and then you start dealing with it piecemeal, right? So it seems to me exact same kind of curve or pendulum swinging, which is initially when the system comes out.
Yes.
People are trying to get the thing to work and do something interesting.
Yes.
And then it realized, oh wait, this is a bad idea.
Yes.
And, it's the same pendulum, just at a different point in the swing.
At some point, do we want to make the same mistake that we did in the IT world?
Oh, we already have.
No, but maybe there is an option. So maybe the point is that you can have two different ways. One of them is, can you do what we did for the IT world by having bolts-on solutions to sort of protect you, even though you went and bought bad devices? Or if you're coming up with a clean slate approach, like a new stack that we've been proposing, is there a way to sort of at least try and think about what primitives would you want from the beginning to sort of, if you had a clean slate approach, could you get to
that's what Java was. Clean slate approach. Anyways, I'm just saying philosophically, it seems to be the same problem, just done now in a different
So should we
context.
stop?
No. I'm not saying that. I'm just, it seems like it's the same pendulum.
Yeah, so I think we learned from the past. I'm saying the goal is that, okay, look, we're here. These are not problems they're already here. Is there something that we can do for this existing completely insecure IoT deployment? And if we had a clean slate, what could we do that could make sort of like, we could build insecurity from there? So that's what I'm trying to do. And you're right, often the ship has probably already sailed at this point, right? We have many of these devices right now. So many of these won't work. You can't really manually learn behavior. How do you know what's normal? Should my smart thermostat be talking to my smart switch and my smart toilet? I don't know. It may be normal for you. It may not be normal for me. How do you sort of learn what's normal and what's not normal? So our solution to try to do this is to say, well, in terms of fixing these unfixable flaws, rather than relying on these end host systems, we feel that the most of the interaction is happening through the network. So your network could become a very good vantage point in being able to observe not only what's happening between these insecure devices, to be able to learn what is abnormal and what's normal, but also provide a point for you to do enforcement in terms of sort of blocking or handling behavior that is potentially a security hole, right? So being able to handle that. In terms of in terms of physical interactions, and the way we've been doing that is using techniques for software-defined networking and network function virtualization that allows you to do very detailed packet processing and being able to sort of come up with rules as to how to handle network flows. Idea being, treat the network as a vantage point to being able to do enforcement and observation. For physical interactions, the idea is that we actually capture the context in which these IoT devices operated, and then figure out which of them are actually normal or not. And you can do this by crowdsourcing, by actually learning from a large variety of behaviors to be able to know what's normal, what's abnormal, and then have more context-based policy abstractions that allow you to sort of detect these problems before they actually happen. And then in terms of diversity of devices, again, a crowdsourcing-based approach where you can learn automatically from behaviors that you observe from people. So while there is this cold start bootstrapping problem, saying that the first vulnerability where your Nest thermostat, I'm sorry, I'm not picking on Nest, thermostat, I realize I would do it now. Yes. So your thermostat is just flushing your toilet suddenly or turning on something, you were like, okay, somebody's house burned down, but can we actually learn like for the future, or at least subsequently, of what may be an attack signature or things that should not be actually happening in the future.
Today I'm working on Google. So what do you actually mean by network-based here? Do you mean device-to-device direct communication, or you mean that we have some kind of...
Yeah, so good question. That is the hard problem. Right? What ends up happening is often if you don't have this gateway model, right? So in an ideal world, you would have something like an on-hub router or something that acts as the gateway where all the traffic goes through that device, right? If on-hub and all of these sort of like smart things hub and Wink hub take off, and the idea is that all your traffic, you have a way to interpose between traffic, not only at different link layers, but at an IP layer. Then you can observe and funnel traffic saying, you are the compromised Belkin smart thermostat or Belkin smart plug, you are the compromised smart oven. Between you two, I'm going to interpose myself and then have different policies of what you can do, because I will prevent you from doing something bad, right? But if you are talking to each other, and I can't like sniff out of the air except block the signal, right? So there are some limitations on even what we can do, right? If you do certificate pinning and do a SSL in the middle and detect that, then often there are many other cases where interposing traffic is also not going to work, right? But assume that in the case that you have some level of IP observability of traffic, and then you can actually have these flexible sort of network function virtualization boxes that allows you to do different processing for different elements. Okay, I'd be happy to talk more about that. This is also a way, if you want to ask me more questions, there are empty slots, come and talk to me after this. Happy to talk more about that. Right?
Thank you.
And this is our vision. I'm not going to go through much detail about how you'd learn the device, who does, who would create this policy, how would you do enforcement, and then what this orchestration layer would be as to that would be able to manage which traffic goes to which processing box. How do you detect and enforce that? Is all this controller. I'm happy to share more detail about this if anybody's interested. And the underlying technical pieces is how do you instantiate all of these micro middle boxes that can then be instantiated on per device or per pair of device interaction? How do you model all of this interaction as a giant state machine? How do you figure out how to process this, right? Because if you think about 50 devices, like the vector of what possible interactions could be is going to lead to a state space explosion, right? You have to figure out how to prune that space to be able to detect and mitigate issues that some of them are innocuous things that should be fine. Some of them are actual attack signatures. So you don't want false positives where you say, look, you cannot do this because all you wanted to do was turn on your oven, right? You should be able to do that without it being flagged as a vulnerability. The current status is we're actually investigating various IoT systems. So we've actually crawled all the IFTTT recipes. We're looking at Samsung Smart Things. So basically all the popular IoT ecosystems. We're looking at all their paradigms in terms of device programming and interaction between devices. We're using first principles to represent apps, devices as using first principles and building out in a model of interaction between them to sort of figure out whether there are safety problems, if there are things that should be interacting that they don't, are there conflicts where certain apps are acting at the same time? So do you have two applications that say, if it's sunny outside, open the window, if it's 6 p.m., close the window, and perhaps you could have these conflicting states where both of them could be open. Or you have two policies that pull different actuators in different places. You have multiple people setting different policies. So being able to detect all of that and be able to identify which particular policies are actually causing problems. So this is actually a work in progress. The whole point to Trevor is this is sort of a bolt-on solution saying that, look, the IoT devices that you have in your system suck, right? They're going to get compromised. What can you do, right? And we have examples of if you had a compromised password, for example, right? You know, all of these devices often have these admin-generated embedded passwords. Can you even deal with those things by interposing that and detecting when there's an admin password and not using that? So preventing it from being actually becoming part of botnet. So we're looking at all of these scenarios and how to sort of have this bolt-on solution. So happy to talk more about this if there's any more questions. And we're also deploying a heterogeneous IoT testbed for that. So buying a bunch of devices, in fact, contacting a number of manufacturers saying, hey, we're part of GioTTo. We would like to, not only for interoperability, but also for security analysis. Could you donate a bunch of devices? Hopefully, we'll be able to get that, or we'll just end up buying a bunch of Z-Wave, Zigbee, all of these devices to actually create an interoperability testbed, but also to understand what sort of interactions can happen between these existing IoT platforms. So if you have any creative ways of getting all of these sort of different IoT manufacturers to donate devices so that we can actually put them in our testbed lab, I'd be very happy to hear that. Now, the question that came up is like, look, this sounds like the train has already left the station. We're trying to do like this post-fact, how do you figure out security? Yeah. If we had a clean slate approach, what could you actually do? Aren't you guys developing GioTTo? Can you do something better since you're like coming up with a stack from the beginning? What could you do if you had control over the underlying hardware and the software stack, right? So we may not be able to address all of these IoT scenarios, but at the very least, you can provide this robust security privacy layer that new applications can at least be written against so that we don't have these vulnerabilities. So, recap, we talked about building depot. Remember, what was the central pop quiz? What was the goal of the central service? Central service stores all metadata, stores all the key value tags, stores all the context information. So, and we use that for permissions, right? So remember central service, which is replicated. So we're going to use that, the key value based system and the templated schema. And then remember we said we have the REST APIs as well as PubSub. And then we have this idea of a virtual sensor, which are either based on machine learning or are computed. So a virtual sensor could also be a raw sensor A plus raw sensor B divided by 2, right? You could do whatever you want on that, right? So on top of these, we built our security layer, which uses industry standard technology. So first of all, we've integrated OAuth. We also integrated HTTPS and SSL. But these are basically transport level secure end-to-end security, encryption, and authorization. What really is at the core is this robust access control layer that we built that allows you to sort of express who has access to what sensor data, under what condition, under what context, right? And the primary way this is built is using this tag system. So the key value tags that are attached to each and every sensor are actually very, very useful for being able to express a wide variety of scenarios. So if you remember access control, if you have N sensors and M users or entities, what is the size of your access control matrix? It's just M cross N, right? Because for every entity, you need to know what sort of permission a particular entity or a user or an app has on a particular sensor, right? So that would be the naive way of doing it. Our idea is that, look, that is too much. And if you have to check all of this all the time, that would be not what most people want to do. If you have a public sensor and tomorrow you want to give access to all the people at Google, you would have to write that by saying, like, look, list each and every sensor in the access control matrix, mark all of them, right? So you don't want to do that, even though eventually for checking you have to do that, right?
Question, going back to your pyramid, right? You know, you're talking about Internet of Things is many devices per people,
yes.
right? Our experience with OAuth in this context is it doesn't work well for that, because you have, you know, it's kind of predicated on a person being there and doing some stuff. And so as soon as you try and roll it out to lots and lots of stuff, as a security mechanism, it doesn't work.
I think you're agreeing to what I'm saying. I think you're saying that if it's too many devices, people, if they have to make so many of these decisions of who has access to what, it's too much cognitive load. Isn't that what you're saying? Or they make the wrong decisions?
What are you saying with this point here? That you are using OAuth 2.0 as part of this?
OAuth 2.0 is just the authorization of who the entity is or who the app is, right? The ACL is specifying what has access to what.
So that's, I guess I'm trying to, there's a distinction there between the applications that are using stuff and the people versus
yes, everything
devices
yes.
and.
Yes.
Okay, so which.
Maybe when I go to the ACL layer, it'll become a little clearer.
Okay.
Yep. But I agree with you that if users now have to make all of these decisions of who has access to what, we need a way, whether for privacy or for security, to be able to help them with these decisions, right? So that they don't have information overload. The smartphone apps accessing your data is already hard enough, right? So as I said, the 3 layers of security, as I already mentioned, the idea is that based on these 3 layers, we can have already a static or role-based access control where you divide users into groups of users. So one could imagine that, you know, the building operating system group could be a group of users. This is how we do, you know, like file system security, right? You have user groups, and then you could have like files or things owned by a particular group. So we have this notion of user group and a sensor group. Sensor group allows you to group sensors together, and user groups allow you to group entities or users together. And then you have a matching of what user group has access to what sensor group. Now, the nice part about all this is that both of them can be defined as a function of the tags. So let's say you have sensors in this particular thing. You say campus equal to Mountain View, right? You say room equal to building equal to 1395 Charleston, room equal to Eva, whatever the room is, right? You could have all the sensors. If all the metadata for the sensors in this room are correctly labeled, then you could have a group called all sensors in Eva, in this particular room are grouped together. You could have a user group saying everybody who is now attending this meeting is now in this particular user group. And then you could have the ability to sort of add these. Now, some of them can be just static, where you're adding these sort of rules and mapping statically. This is what happens in current access control. Now, in case of IoT, the hardest part is that, look, it's going to be super dynamic, right? You want something else. You want to say, Yuvraj does not have access to the projector in this room, except when he's here, right? I want to give you a location proof saying, I am here, and because I'm in close proximity to you, I have access to some of these resources. So we call them context-driven or dynamic access control. Primary one being location and proximity. And the nice part is we've actually started to implement abilities of being able to add these dynamic context rules that are based on your sort of location and other aspects right now. And one of the demos actually uses location and Bluetooth Low Energy beacons as being able to give you sort of like different permissions and different access based on your proximity or your absolute location, right? So the stack system allows you to do all that. So that not just for static access control, but also for much more dynamic context, because now you're composing these groups and users based on pure checking of key value tags. And we know how to do that very quickly, right? Now, searching for this again is based on this. So the tag system are important because the key values are important to search for. That's what define the groups and the sensor groups and the user groups. The access control that basically says that, actually this is an easier slide to understand. is like you have a user group that says user group contains user A and B. This is a very simple example. The sensor group is defined by these tags: building equal to Jacob, floor equal to 1, right? So every sensor group, the sensors in this group are defined by this, and it's an inexact match. So if there is some other sensor that has a different tag, it will still be part of the same sensor group. So you can make sensor groups more restrictive by adding more tags, saying building equal to Jacob, floor equal to 1, owner equal to Yuvraj, right? You can define however fine the you want, and then you add a mapping of which user group has access to what, right? And we've even got concepts such as read, write, actuate, delegate, meaning can you actually give permissions further on? Because this is an administrative nightmare, right? When Google Campus was created, all the building management sensors would belong to the head campus building manager, but they want to give access to individual people. So we have an idea of how to delegate permissions to different entities. Go ahead.
So within sensor group, you also are including your notion of virtual sensors.
Yes. So that's a cool idea. So that's a cool thing that you do. So now the point is that, remember what I said, this lends itself very well to this notion of privacy tiers, and I'll talk exactly about that. But you could imagine, let's say you have an accelerometer, right? An accelerometer, based on the accelerometer, you create a virtual sensor called the knock sensor. Did I knock or not, right? Both these sensors could share all the same tags, but you could add one additional tag for the virtual sensor called virtual sensor, or say privacy tier low, right? So you could have a sensor group that says privacy tier high for the raw sensor and privacy tier low for the virtual sensor. So when anybody's searching, they could see that there are two different, like in terms of activity or recognition in this sensor, I have multiple sensors that are returned, but they're separated by these tags, right? And you could build this notion about privacy tiers on that, right? So exactly. So they would share most of the tags, but you can add additional tags depending on how you want to differentiate them.
I have a question here as well. Yeah. If you're about to get to it, no worries. Yes. What is the identity model that you have for users? Does it include only kind of very strict identity, or can things like just presence in a room, for like I should be able to turn the light switch on?
No. So for the OAuth, the idea is that your identifier is your email, right? Of making sure, and even apps have to have an email as an identifier of that you are like this entity, right? And you could replace that with something else that you want, but it allows us, using email allows us to authenticate who you are by sending your one-time pad saying, do you have access to this email? We can create accounts for everybody at Carnegie Mellon, right? By sending it to their email, and then.
So that's a hard requirement. You must go through email-based.
For the static sensors, right? Uh-huh. So every entity, whether it's app or user, has to have have an identifier, which for us is the email, which provides us a mechanism of also to authenticate whether they own that email, right? Now for dynamic access control, it's different because now you have location as a proof of I am here. Now location as a proof is not as trivial as you think, because if the initial version was just looking at BLE, like proximity to a Bluetooth low energy tag, right? But if I give that as a key equal to location equal to BLE tag, you could replay that, right? You could just say, I'm not even here, I'm going to be outside, right? So we've been investigating now how using ephemeral IDs and other methods will allow you to at least still validate that the person really is here. So one example that we've been looking at is just pure RSSI-based fingerprinting and Wi-Fi can tell you, sort of provide it'll be a harder to spoof method of are you actually here or not, right? If you have control over the BLE beacons, you could do all sorts of clever things, right? Because maybe you just have a duty cycle or something or the other. But these have become these are things that we're very, very interested in. We're building all of that into our super sensor because we want to put all of that control in the sensor itself, and also have the sensor broadcast a URL for the privacy policy about what sensor is doing. So turns out the super sensor can do lots of, we don't like the name super sensor. If you have a better name, we're calling it iButton. We have 20 different names. Super sensor was the best we could have come up with.
That probably happens when you have the next sensor. Right?
The next sensor. Super sensor plus sensor. Maybe just call it SS 10.1, like the Apple Mac has been doing.
Sorry, this question sounds like slightly stupid. Where does the web of trust thing comes from? The OAuth, the HTTPS. So the scenario I'm thinking is I don't need. So supposing I'm in control of this room. Supposing I am an occupant in this room, I'm the main occupant in this room. Yes. I should be able to give you permission to access data from a sensor in this room. You don't need to have to go to all the way up.
Yes.
Right?
So what would happen is,
you sign something with.
yes. So I think the way you're saying is how you bootstrap the system, right? Like I've deployed all the sensors. I want the user or the owner of a particular room to already have some permissions, right? So the use model right now would be, especially in case of building management systems, you have these drivers that are pulling all the backend data, right? You should be able to turn on the temperature in your room, right? So that would be admin, right? Okay. Then using LDAP, so we've written drivers to just do LDAP and like look at the directory to be able to know who's the owner or the occupant of a particular room. The building manager would delegate the occupant of that room as somebody who can read, write, do whatever they want on a subset of the sensors and also delegate that further.
So the system also needs to figure out that I actually own that sensor, right?
No, so that would be static. So for infrastructure sensors, it would be specified, like if somebody else imported that sensor or actuator, like something that was existing before you even came here, it would have to be the building manager who then delegated access to you, okay. Right? Right.
And that falls into the sensor group.
Sensor groups and user groups, exactly. Yes.
Okay.
But you're asking also like, okay, but how do I know? This sounds like a nightmare in the beginning of like 30,000 people. How do I? Well, you know what, LDAP, all sorts of other side channels you already have, right? So we've got an LDAP scraper that figures out exactly whose office is at, right? There's no problem with that.
So that also handled, I guess, the counterexample if I came in and I was maliciously going to install a malicious sensor in a room that had other sensors.
So that's a very interesting thing. So this was the problem saying anybody, the current model is anybody can install any sensor and assign any tags to it. Because we didn't want the sort of additional step of me having to get authorization from somebody to being able to install a tag here. So I come in here and say room equal to EVA Acrobat and I just put a sensor here. Many details here, we handle that because there's a notion of who's the owner and who owns the tag space. So that just by, because what if I say you had something that says if occupancy high, if occupied, turn on the light, and you just said, I'm going to put in a new fake occupancy sensor. You can't actually do that, right? Okay. So it prevents you can add it, but it's not going to be useful for anything.
I can add it, but I can't.
You can't do it. You can't actuate based on that, right? So,
gentlemen, let's dig deeper in conversations in the afternoon or over email. Yeah. We're eating into an In's time, which is horrible on the one hand, but makes him going to have a more impactful
I thought we were going to say
presentation. I speak much faster.
You can auto-learn your talk. Okay, so anyway, and then there's this whole point about why does IOC privacy matter? We talked about security and safety. You know, this is like one of the biggest things here. So even talking about the super sensor on our campus, you know, some people have already said, hey, so what happens? What are you sensing? Is there a microphone? Where is the microphone? Are you taking audio data, etc.? So privacy is going to be this sort of, we think, and I hope it's not just an academic environment thing. I think it's going to be pervasive that we need to figure out what to do. And we've already seen many examples of where people could use what were seemingly innocuous for things that you didn't even think were possible. So how do you look at your car insurance bill? And many studies have already done that in smartphones, people don't even install apps because of the privacy problem. Right. And we think that IoT is going to be even a worse problem than that, right? So we talked about the taxonomy of IoT privacy threats. Some of them, and I'll only go through some of them just in the interest of time, is the depth of sensing. How rich is the underlying model, right? The trouble with this is that it's unclear right now, if I give you a raw sensing stream, what inferences you could potentially make. So take the same sensor stream, 3 years down the line, somebody might come up with a better algorithm and make inferences that you didn't even think were possible, right? But at a high level, you need to be able to know how rich the sensing and the user models are, what the temporal scales are, what are the other third-party software that can be run on the device and use that applications. So same pyramid that we've been using before, multiple tiers of privacy. In the bottom tier, the trouble is that's where we are. We have no awareness of devices and apps because you just walked into this room. Do you know what sort of sensing is happening in this room? Is there a big display that tells you what is being sensed about you? You come into my office, I've already allowed to sense everything about me, but now you come into my space. Does that mean you get notified what is actually happening? So there's this notion of, you know, who has control over what's actually happening that is pretty challenging. The primary idea that we've been looking at is how do we make sort of information flow visible, right? And like for the bottom tier, as we talked about, we're going to be sensing all sorts of sensing data. So some of it we're by default designing that we do not sense. So we have a microphone, but we only sense spectral features and sort of intensity, not really the raw audio, because that's no way that's going to happen. We decided specifically not to include a camera, but we have a very, very sort of coarse-grained 8x8 pixel array that sort of allows you to sort of track movement or something, but not really sort of faces, etc. And the question is that on this sensor, we want to add new notification modalities so that you can actually figure out what is being sensed and sort of in a way that users actually understand it. And I'll explain what that might be. So the long-term privacy and security issues are, how do you design for awareness? If they're under the assumption that you must notify users about practices that are happening that are not normal for them, how do you design the system for awareness? How do you facilitate privacy and security in low-end devices? How do you determine useful defaults, right? Now, I just said we have hundreds of devices, and now like many of them have many different sensors. There are many users. How do we make sure that people are not overwhelmed with the number of choices? And the various things we're looking at is like, how do you make this trade-offs in terms of notification? Should it be audio? Should this have a little mic, like a speaker that sort of notifies you about sort of newer things that might be happening? How do you come up with a cost-benefit model of notifications? What kind of middleware infrastructure do we need for basic privacy and security? I can talk about that because we have a little video of that, so you just see it. How do you do useful defaults for sharing? Can we figure this out based on people's mental models? Can you define what a notion of friends, close friends, acquaintance are so that it becomes easier for people to decide what is okay and suggest the useful defaults? And then finally, there is this paradox. Can I use big data to actually improve your privacy? So this sounds counterintuitive, right? In order for me to propose useful defaults for you, maybe I need to know who your closest friends are and what your trust model is. Maybe that could be gained by who do you email the most. Maybe it could be gained by who's your friend on Facebook or social networks, who do you share the most with. But in order for me to understand that and build a model of your friends and acquaintances and relationships, I actually need to mine data about you. So there is that sort of this paradox. You could get lots of useful information, either the user supplies it or you actually learn it. But we think that understanding where this sort of trade-off is and how to make it easier for people to sort of not be overwhelmed by these decisions are going to be important. So, and you can make purpose of data more explicit. We're developing new programming abstractions. So people program to APIs, not raw data. Very similar to virtual sensors. People don't, so often if you ask users, and this is like not just like a conjecture, we've actually run surveys on our campus as part of the IoT expedition to understand whether people are more comfortable with sharing I'm at home and work as opposed to my exact GPS location, right? People have like same thing about inferences, right? I'm busy or not is very different than sharing my underlying data. I'm in Pittsburgh or not is very different than, like raw level data, right? So APIs can be organized into tiers of privacy. And then understanding how people's concerns vary as you give them different privacy sort of like granularities is something that we're very interested in studying over the next year. Some of our students actually came up with new ways to notify users about these privacy snafus that might be happening. And there's a site called Signifiers.io. I welcome you to take a look at it. These are a group of masters and NCI students that were advised by Jason. And they came up with all sorts of different ways where current IoT devices or new IoT devices could have the right notification modalities so that unambiguously it could let users know that there is something happening that is privacy invasive for them. Let me just quickly show you a demo of this, if this works. So this idea is like, this is the privacy tiers. So example is that you log in using your ID, for example.
And soon.
Okay, and then this is showing you what your grouping is, friends, acquaintances, and people. It explains what have you set up as a policy. Tier 1s are friends, and tier 2 are acquaintances, and then you define that what is tier 1. Your friends are placed automatically in tier 1. Any of them can query a particular sensor at different privacy tiers. So you could have the same sensor stream and have multiple different virtual sensors showing you different privacy tiers. And depending on who you put in each of these tiers, the data that they get could actually change. So I'm adding different people to different tiers. Now this is where mining who's my friend in the quintessence would be useful. So I'm done.
Thanks for the talk.